Hey guys, so I had to leave early today, so I'm just leaving you this little video to watch to complete day 2 of notes, okay? As always, when I come back to see you on Tuesday, I'll go over this again briefly with you, but please make sure you watch this video in detail. Okay, I will not be reteaching the whole lesson, but I will go through it with you again, just what we cover. Alright, first thing that we're going to look at is stuff that we did last class, okay? Starting off with reference angles. So just to talk about notation again, reference angles are always made with our angle symbol with a little like prime bar, we call that. All right, but it's just saying theta apostrophe. Okay, this is our notation for reference angle. We have to remember that it is always positive and it is always acute, right? Acute meaning less than 90 degrees. And it is the angle made with the closest x-axis. Okay, so just to very briefly go through each quadrant with you. If your angle is in quadrant 1, then your reference angle is here. Okay, if your angle is in quadrant 2, then your reference angle is here. If your angle is in quadrant 3, let me get another color real quick. My pen hasn't been working, so let's see if this goes. Then your reference angle is here. Okay, if your angle is in quadrant 4, then your reference angle is here. All right, so notice it's always the angle made with the closest x-axis. All right, so that's the big idea. So when we solve for reference angles, we always start off by sketching the angle given. Okay, so here we're going to start off by sketching 410 degrees. Okay, if you are not sure where it is, start by finding its coterminal angle. Remember, that's vocabulary now from your quiz. All right, so we are going to start off by finding its coterminal angle. And let's see, what does that get us? 410 minus 360, that's going to get us 50 degrees. Okay, so what that tells me is that 410 degrees is sketched like that. That is our whole angle given. Now, when it wants you to find the reference angle, it's only asking for this part made with the x-axis. All right, so what we see is that this is 50 degrees away, because we're getting that from our work here. Since it's in quadrant 1, it is 50 degrees away from our x-axis. So here's our reference angle. Okay, it says that this is 50 degrees away from x-axis. All right, moving into number 2. All right, you have negative 210 degrees. All right, once again, think about negative would just mean we're going in the opposite direction now. Negative 210 would be here. And this would be our sketch of our angle, right? So this is stuff that you guys did last week that was on your quiz. When it asks you for the reference angle, it wants this here, right? This is how far your angle is from your horizontal axis. So what I want you to think about, if you know that this is 210, or negative 210 rather, first step we have to do, because it's a negative angle, is find the positive coterminal angle. Okay, so we're going to do negative 210 plus 360, and we'll get 150 degrees. Now, the reason we do that is because this math is going to help us figure out how far away my angle is from the x-axis. If I know this is 150 degrees, and I know that there's 180 degrees on the far left, then to find the reference angle, I have to do 180 minus 150 degrees. So 30 degrees will be my reference angle. Okay, once again, reference angle is always positive. So what I first had to do was find the positive coterminal angle. Then find reference angle. Okay, remember this is talking about how far away you are from your x-axis. So this is 30 degrees away from your x-axis. All right, going into 3. Now at this point, if you want to pause the video, try these two on your own. Okay, see if you get the same answer as I do. I'm going to go a little quicker now. I know 145 is in quadrant 2. I know my angle is sketched like this, 145. Reference angle would be here. To figure out what that is, I do 180 minus 145 equals my reference angle. And we would get 35 degrees. And that would be my answer. Okay, over here, 310. I know that sketch is going to be in quadrant 4. My reference angle is made with my x-axis. I know a full circle is 360 degrees. So to find my reference angle, I do 360 minus 310. And that angle is 50 degrees away from the x-axis. Okay, so this is my reference angle. All right, the second part we did in last class is we used reference angles to help us determine the exact values. So this is what we're going to review real quick here. All right, just to remind you of that exact value chart. Next class, when I'm with you, because it's a little confusing over video, I'm going to show you a real quick shortcut of how to make this chart really fast so that you don't fully have to memorize it. Cosine theta, sine theta, tangent theta. Remember, last class we only worried about 30, 60, and 45. Today we're going to start adding in a little bit more, but this is from last. All right, this is going to be root 3 over 2, root 2 over 2, 1/2. Now remember, we solved for this, okay? We solved for this by using our right triangles, our special right triangles. So if you aren't sure where I got this, go to last class's notes, okay? We got this from our right triangles. That's how we're creating this chart. Right, and then tangent was root 3 over 3, 1, root 3. Okay, so now we are going to use this to help us evaluate other types of angles, okay, based on the reference angle. So, step 1, right, sketch 210. So I know that 210 degrees is going to be here. When I'm in quadrant 3, my reference angle is going to be this spot. To determine that value, I'm going to do 210 minus 180, and I'm going to get 30 degrees. Now, step 2 is going to be, look at your chart, what is cosine of 30? Going over here, so now you have to know the chart, okay? You have to know this. Going over here, cosine 30. This answer is radical 3 over 2. Okay, but that's not our final answer. The third step is going to be look at the quadrant, right? So what quadrant are you in? We are in quadrant 3. And we are looking at cosine. Okay, so think about all students take calculus. In quadrant 3, the only thing that's positive is tangent, which means that cosine is negative in quadrant 3. Okay, so what's going to happen here is we're going to have cosine of 210 is equal to negative radical 3 over 2. And this would be our final answer. All right, similar steps as we move on. Now, if you're feeling comfortable with this, feel free to do the work on your own and then just check the answers with the video. If you want more practice, follow through, okay? All right, first step, let's sketch negative 135 degrees. So I know that negative 135 is going to be about here. Right? I want to know how far away is this from the x-axis. So a good way to do that is think about what is the positive coterminal angle. If I do 360 plus 135, let me rewrite that. Negative 135 plus 360, that's going to get me 225 degrees. And now the reason I do that here is just because it makes our math neater. Okay, because now in step 2, or I guess is this still step 1? I guess this is still step 1. When I now find my reference angle, I'm going to do 225 minus 180 to get 45 degrees. Okay, so this is my reference angle. Now I'm going to use that in my second step. Okay, step 2 is sine 45 degrees. So once again, we go to our chart, we look at sine, we look at 45. This is radical 2 over 2. Since I'm in quadrant 3, and I know sine is negative in quadrant 3, this final answer is going to be sine negative 135 degrees equals negative radical 2 over 2. All right, and that's your final answer. Once again, if you want to go through these problems, just check your answers to the video. Feel free, so you could skip through this part. If you want to watch more, it might be a long video, so just giving you a warning ahead of time, but you don't have to watch every single step if you're getting more comfortable. All right, 420 degrees we know is going to be in here. We want to know the reference angle. So at this point, what we have to think about is that if I do 420 minus 360 degrees, I will see that my reference angle is 60. All right, step 2, sine of 60 degrees. We go to our chart. Our chart is saying sine 60 degrees, radical 3 over 2. Over here then, we will have radical 3 over 2. My angle is in quadrant 1, and we know that sine is positive in quadrant 1. So sine of 420 is equal to radical 3 over 2. All right, last one, tangent of 120 degrees. I have 120 degrees in quadrant 2. I should make that a little higher, actually. There we go. Bad sketch, sorry about that, but this is 120. My reference angle is made with the x-axis. I know this is 180. Reference angle is 180 minus 120. Once again, 60 degrees. So first step is I take tangent of 60 degrees. I use my chart. Tangent, 60, radical 3. Okay, I am in quadrant 2. So I know tangent is negative in quadrant 2. Right? Once again, I'm getting this from All Students Take Calculus. So I'm going to have tangent of 120 is equal to negative radical 3. Oh, sorry. Hit my arm. And there you go. So this is our review from last class. Okay, we found reference angles. We found this exact value chart. And then we use that to help us evaluate trigonometric functions, okay, for exact values. Moving on. Okay, now what we're going to talk about today is quadrantal angles. So it's basically exactly what we did last class, but last class we found the angles between axis points, right? So here was 30 degrees, here was 45 degrees, and here was 60. But we never looked at 0, and we never looked at 90 or 180 or 270, right? We didn't evaluate those. So these are the points that we're going to start evaluating today. Okay, so what we're going to first introduce is just something we call the unit circle, which is what we've been working with so far, but we're just going to start formally introducing it. Okay, the main idea is that when we work with this thing called the unit circle, okay, it has a radius of 1. That's going to be very important for us. Now, remember, when we are working here, our circle always starts at 0 degrees. Okay, then it goes to 90 degrees, then 180 degrees, and then 270. If this has a radius of 1, what I want you to think about is that this distance is 1 in every single direction. So when I go to the right of my triangle, I'm moving to the right 1, and I'm going up none. When I go to 90, I'm not moving left or right, but I'm going up 1. When I go to the left 1, up none, down, left and right none, down 1. So these are the points now that we're going to start including into our exact value chart. Okay, we're going to start using this information to help us evaluate trig functions. All right, now before we do, we kind of talked about this a few times in the past. Okay, something I just want you to recognize. So far, we've really referred to our sine, cosine, and tangent with SOHCAHTOA, right? So if this was opposite, adjacent, hypotenuse, we're really going to start referring to it now as x, y, and r. Okay, so sine is now going to correspond to y over r. Cosine is x over r. Tangent is y over x. And now these are all the reciprocals. So this is what we start using as we move into the unit circle. Okay, so we kind of get away from that SOHCAHTOA and we start moving into talking about like your x direction, your y direction, and your radius. All right, and now we're just going to go through a few of these problems. So main thing, we are going to take this, we're going to take this information, and we are going to apply it down here when solving. Okay, also, we are going to add to our chart. Oh, sorry about that. So, what we did in the do now, we had an exact value chart, and we only had 30 degrees, 45 degrees, and 60. We're going to add a little bit. I might have made too many rows. Let's see. Here now we're going to add 0, so 0 degrees. Then we're going to add 30 degrees, so that's what you already know. I definitely did not leave myself enough room, so let me move this over a little bit. All right, 45 degrees. This is going to be a little messy, sorry. I'll do it again with you in class. And then 90. All right, then we have cosine, sine, and tangent. Yeah, so I made one too many. Let me get rid of that last row. Precision. All right, at this point, the 30, 60, 45 rows are going to be the same as before. Now for cosine, this is going to be 1, 0, okay, and then this is going to be 0. This is going to be 0, 1, and then we're going to say this is undefined. Okay, here's where this is coming from. When we're looking at the 0 degrees on our unit circle, okay, what I want you to think of is up here, your cosine, your x value was 1. Now what we know about our ratios is that when we're setting this up for cosine, if you have x over r, then you have to do 1 over 1. Okay, this is for cosine of 0. Oops, sorry. So we'll go over this a little more in a bit. So we're adding now our exact value chart. So here was 3 over 2. Okay, this ended up being radical 3 over 3. 1, radical 3. So now this is what we're going to start using to evaluate. You do have to know this, okay? So you're going to have to memorize this at some point. Moving into our examples, though, just to show you what this looks like. When we think about our unit circle now, it's asking you to evaluate sine when your angle is 0. What we know is at 0 degrees, we have a coordinate of 1, 0, because we are moving to the right one, because that's our radius length, but we're not going up and down any. So at this point, we know sine of 0 is equal to y over r. Okay, this is coming from the chart above. Your y value at 0 is 0. Okay, so sine of 0 equals 0 over 1, because the radius of a unit circle is always 1. His answer is 0. Okay. Tangent of 90 degrees. So we know that at 90 degrees, based on our radius, our point is 0, 1 on my unit circle. Now we know that our ratio, tangent of 90, is equal to y over x. Well, at 90 degrees, my y value is 1, and my x is 0. Now, we can never have 0 in the denominator, so this is undefined. Okay, secant of 90 degrees, negative 90. Once again, here's my unit circle. I know that negative 90 degrees is down here, and that point is 0, negative 1. I know that secant is the reciprocal of cosine, so this is going to be equal to r over x. Your r is 1, and your x is 0, so this is also an undefined ratio. Okay, notice it's just like what you did in the do now. You're just now looking at different angles. In this chart, right, if we go to tangent of 90, tangent 90, undefined. Okay, secant. Secant just means you look at your cosine and you flip it. You take the reciprocal. Okay, that's how we're getting undefined. Now, a bunch of kind of practice problems. What I'm going to do is I'm going to go through it. So at this point, if you feel like you're understanding, you could end the video, right? Just look at my answers to see that you're on the right page. If you're still struggling, kind of follow along with the work at each problem. And we are done from there. Okay, I'll review this a little bit with you guys when I'm back in class. We know that cosecant of 180 is equal to r over y, 1 over 0. I didn't realize how many undefined ratios I gave you guys, but this is also undefined. All right. Now remember, cosecant's a reciprocal of sine. Okay, that's why we do r over y. Cotangent of 360. Here we have 360 degrees is a full circle. Our ratio is 1 over 0, 1 comma 0. My ratio for cotangent is x over y, so big surprise once again. 1 over 0, we get an undefined ratio. All right, UND, I didn't really say this, but hopefully you caught on. This just means undefined. Just my abbreviation. All right, cosecant of negative 270. Once again, think about your circle. Negative 270 is up here. You have 0, 1. Cosecant ratio is r over y. We know the radius of a unit circle is 1. Your y value here is also 1. So this whole thing is equal to 1. Now, this is going to be a common theme as you guys are working with quadrantal angles, meaning any angles on the axis. You're either going to get 0, 1, or negative 1. All right, last few. I know that a full rotation, here's 360. If I keep adding 90, I'll get 450, and then I'll get 540. negative 1, 0. Cotangent is x over y, which is negative 1 over 0. So this is undefined. Cosine of 720. I know that 720 is 2 full circles. 1, 0. Cosine is equal to x over r, which equals 1 over 1. Last one. Sine of 90. 90 is on the top. 0, 1. Sine is equal to y over r, which equals 1 over 1, which equals 1. All right, so once again, it's just evaluating trig functions. So if I'm asking you sine of an angle, you're always going to have a ratio at the end. So that's what we're solving for. We're solving for ratios. And now, based on the unit circle, we know our radius is always equal to 1. So we use that when we're setting up our fractions. All right, next class, I'm going to show you a real quick way that we can make this chart together. For now, I'm just going to fill it out for you. All right, root 2 over 2, 1/2. And now this really is the essence of like what we're going to do for the next, honestly, until the end of the year. So as we get more comfortable with this topic, we will continuously use it. Y for x. So please make sure to bring in all of your questions when I see you on class on Tuesday. We're going to have a big review day just of this video and then what we did last class. And then y for x. Nope, sorry. Undefined here. And there is your chart. All right, so that's the end of this video. It seems long, but it's really just because I'm going through every single example. Hopefully you guys skim through. If there are parts that you feel confident with, you can move on. All right, at the bottom, give yourself a rating. How are you feeling with this lesson, 1 through 4? And bring in any questions on Tuesday. Have a great weekend, guys. I'll see you then.